Hi there. Welcome to our revision lesson on trigonometric equations for the guys in the first year of the 2-year higher. Now, we're looking at this obviously because some of you, a lot of you have some issues in terms of looking at how to solve the trig equations. And I just want to give you an opportunity to go through it, really right the way through it again and see if we can kind of simplify it for you a little bit. Now, it's Friday afternoon after school. I'm going to try and do it all in one take, so there are going to be mistakes, just bear with me. Now, coming into this, I'm not going to look at any of this stuff, so it's stuff that I want you to understand already, and for the most part you will. Okay, I want you to understand and know how to use and work with radians. I want you to have a good understanding and knowledge of your exact values. If you need to look them up at the minute, that's fine. Obviously, you've got a long time to do that, but you do have to be aware of them. I want you to know your double angle formulas, so you understand and can substitute in. And I do really need you to have a good understanding of how to use the cast diagram and how to solve simple trig equations like you would have at National 5. Now, the reason I'm going to ask you to know all that is because I'm just wanting to focus on the equations. If we can start out, I think we'll be a lot better and a lot more comfortable all in. Now, the reason I think that people find trigonometric equations so tricky is there are a lot of tricks. Okay, there are a lot of tricks that you need to be aware of, and there's a lot of tricks you need to know. Now, I want to take away all that kind of that decoration, all that show, and just look at, right, there's two methods we really need to know. You can dress it up whatever they like. SQA can do whatever they want to try and trick you, but there's really two methods at this point that we need to know. Okay, and I'm going to call them method 1 and method 2, imaginatively. Now, method 1, I'm going to use when you have only one trig identity there. Okay, so when you have only one trig expression in the formula. Okay, so only one sine, only one cos, only one tan, and nothing else there to do with trig. Method 2 is when you have two different trig terms. So you have a cos 2x and a sine x, or a cos 2x and a cos x, or a sine 4x and a cos 2x. Okay, so we're going to split them up, and just for this slide I just want to show you what one would go where. So this one at the top, okay, there is only one sine, so it goes to method 1. There is only one trig identity, there is only the sine, so that goes to method 1. And this one here, there is only one cos, so that, oops, still got a pen in my hand, there's that first mistake. Okay, so that goes to method 1 as well. With this one here, let's get rid of that green stuff. There's two, in that equation, there's two different trig stuff. Okay, there's a cos 2x and there's a sine x. So that one's going to go to method 2. And we'll look at what these methods mean in a wee minute, but I just want to be able to identify first. This one trig term, method 1. One trig term, method 1. Two trig terms, method 2. 1, method 1. 1, method 1. 2, method 2. Okay, so you can see there the difference, and I've cleverly used method 1 if there's 1 and method 2 if there's 2, but that's how we have to identify. Now I'm going to look at 4 examples from method 1 to show you how essentially what we're going to do. So the first example's there. Now when you only have one trig term, you're going to solve it the same way you solve the basic equations. You need to get everything away to the other side, so you're left with x at the end. Okay, so you want to isolate that x, and you're going to do it by getting rid of the plus 3, by getting rid of the 2 at the front, by getting rid of the cos, and by getting rid of the 2 in front of the x. Okay, so you know how to do that. You've worked with it with basic equations, and we're just going to do that, but with trig this time. So the first thing we're going to do is we're going to take away 3. So it will be, in fact, let's move that, give me a bit more space. Okay, so the first one is going to be 2 cos 2x. When you subtract 3, it's going to take you to negative 1. Divide by the 2 to get rid of it at the front, so it's cos 2x is equal to negative 1/2. Now the next part is getting rid of that cos. So we get rid of cos by doing the inverse of cos. So 2x is going to be the inverse of cos of negative 1/2. Okay, now we know, this is where our cast diagram comes in, we know that if we're going to do that, we're looking for the cos in two quadrants. Okay, it's cos, it's negative, so we're going to be working in the sine and the tan. And we're going to be using inverse cos of a half in those two quadrants. Now we know from our exact values, inverse cos of a half, well that's 60 degrees. Okay, notice we're working in degrees at the top. So when we put them into those two quadrants, 2x is going to be 180 minus 60 for the sine in there, so 120. And in that quadrant there, it's going to be 180 plus 60, so 240. Now the answers you've got there is for 2x. We're not really interested in 2x. We want to know what x is. So the last step is, in terms of solving initially, is to divide it by 2, so it'll be 60 and 120. Now the last thing we have to look at is, well, that range, those answers have to be between 0 and 360. And we know that from a cos graph, or a cos 2x graph, sorry, just going to move this down a wee bit. From a cos 2x graph like we had at the start, well, when you have cos 2x between the 0 and 360 that you're looking at, you're going to have two waves. So when you're looking at negative a half, you're going to have four answers. These four here. So we've got the first two okay. That one's going to be 60, that one's going to be 120. But because it's a 2x graph, these answers will repeat every 180 degrees. Okay, so my last step to make sure I get all of the answers is to add on 180 to both answers. So it's going to give me 240 and 300. Okay, now I don't want to get away from my two different methods. Okay, we're looking at a single cost term, right way back at the start, we're looking at a single cost term, no other trig. So the basic method is get everything to the other side. So take away 3, divide by 2, get rid of the cos, then divide by 2 down here. But there's wee tricks and stuff we have to stay on top of. So we need to consider all the answers like we did in here. We need to make sure we're using our cast diagram properly like we do in there. But the basic method is the same. One term, method 1, get everything to the other side. Okay, so that's our first example there. Second example, very similar. A little bit of a difference though. The dreaded pi coming up in our range, so we're going to be working in radians this time. But we do only have one trig term, so we're taking everything to the other side. So we subtract 5. So 4 tan 3x is equal to negative 4. So tan 3x when we divide by 4 is going to be negative 1. The next thing to go is that tan. Okay, next thing to go is that tan. So 3x is going to be the inverse tan of negative 1. And we know to do that inverse tan of negative 1, we need to use our cast diagram. So we go to our cast diagram, we're talking about a negative tan, so we are in S and we're in C. And we do the inverse tan of 1. We know it's 45 degrees, but I'm working in radians, so my radians for 45 is pi over 4. And when I put pi over 4 into these two quadrants, my sine and my cos, 3x, well, in this quadrant here, in the sine quadrant, it's going to be 180, or pi, subtract pi over 4. Now that's just fraction work, it's going to be 3 pi over 4. So 3x is equal to 3 pi over 4. Okay, in the cosine quadrant, it's going to be 2 pi subtract pi over 4. Now you can extend the fraction work and do it properly if you want, but I know that in 2 pi there's 8 quarters. If I take away 1/4 of that, it's going to be 7 pi over 4. Okay, so 7 pi over 4 for that second answer from the fourth quadrant. Okay, now we're still working our way through our different thing. We're still got to get rid of that 3, so we'll divide everything by 3, which when you're working with radians is going to give you an extra factor of 3 down here in your denominator because you're dividing by a 3. So that will be 3 pi over 12. Okay, and 7 pi over 12. Now, again, we've got to consider the period of the graph. So with a graph of 3x, that repeats every 120 degrees, or really that's 2 pi over 3. Okay, for 120, it's 260, so 2 pi over 3. So we're going to add on 2 pi over 3 every time until we go over our range, which stops at pi. So 2 pi over 3 really means, well, 8 pi over 12. Okay, so that's 8 pi over 12, so we've got the same denominator. And when I add on that to 3 pi over 12, will give me here 11 pi over 12. Okay, if we add on 8 pi over 12 to 7 pi over 12, that gives us 15 pi over 12. Okay, let me check my answer, the range at the start. Okay, the range only goes up to pi, you'll see there. So anything over pi can be discounted, so that 15 pi over 12 can be discounted, and that's your final answer. Okay, now again, one term, method one, get everything to the other side. If you can deal with your cast diagram, which we know how to use from that 5 stuff, if you can deal with radians, okay, in this question, that's important, and if you can deal with the period at the end, then everything else is just little tricks related to that. Okay, next one here, we're back in degrees, we like degrees, but again, only one trig term, so our method one, get everything to our side. So first thing to do is to add the one, subtract the one to get rid of that plus one at the start, so that's 5 divided by 5 equals 1. Next up, we're getting rid of that tan. So we're going to do 2x minus 40 when that tan's gone is equal to the inverse tan of 1. And we know if ever we're taking inverse tan, we need to go to our cast diagram. Okay, we're talking about a positive tan, so we're in A and T. The inverse tan of 1, we know is 45 from our exact values. So when we put it into that first quadrant for the all, I'm changing colours like mental here, that's just going to be 45, so my answer is 45 degrees. And in the tan column, that's coming back, going on to 180. So 180 add 45, so it's 225 degrees. So 2x minus 40, let's try and get back to green there. 2x minus 40 is equal to 45 degrees and 225 degrees. Now we've still got a little bit of solving to go on here. I've got to get rid of that minus 40 and I've got to divide by the 2. So 2x is going to be 85 and 265. So x is going to be 42.5 degrees and, oh, fast math, 132.5 degrees. And again, we've got to consider our period. We're talking about a 2x now. So that repeats every 180. So if I add on 180 to 42.5, that's, oops, let's put that in green so my answers are the same. Well, I'll add on we'll add on 180 to 42.5, that'll be 2.5 degrees. And do the same thing there, add on 180. That will give me 203.12.5. Okay, now you could add on 180 again, but that's going to take you over the 360 at the top. So that's your final answer done. Okay, now I know that's a bit messy. I'd maybe be looking at you set it out a little bit too. That's just my kind of rough working for solving the tan. But you can see everything's kind of the same. Okay, you're adding. You've got one thing, method one, get everything to the other side. You'll deal with the cast diagram when you get there, you know how to do that. You'll deal with the period at the end, you know how to do that. Okay, I think I've got one more example here. This is going to be a very long video, I've got the sense. And you can see a little trick coming in again. Firstly, I'm looking is radians. Okay, brilliant. Love a bit of radian work, but that squared coming in is a little bit tricky as well. So let's see how we're going to deal with that. Okay, again, we've got one trig term. We've got one trig term, so I'm going to get everything to our side and solve it like that. So take away 5, so 6 sine squared x is equal to 3. Divide by 6, so sine squared x is equal to 3 over 6. 3 over 6, we don't want to write that, do we? We want to write that as a half. That squared now, we need to get rid of. Okay, so we know that sine squared x really means all of sine x squared. So to get rid of that squared, all we need to do is square root. So the square root of a half, so sine x is equal to the square root of a half, which remember is the positive and minus of 1 over root 2. Okay, so x is inverse sine of the positive and negative 1 over root 2. Now we know when we're getting rid of a sign we need to go to our cast diagram. The trick here is we've got positive and negative, so we're ticking all 4 quadrants because the 2 positive are at the top 2 and the 2 negatives will give me the bottom 2. Okay, and inverse sine of 1 over root 2, we know it's 45, but we're not talking 45, we're talking radians, so pi over 4. So my 4 quadrants I need, let's turn back to blue, the all will just be pi over 4. The sine will be 180 subtract pi over 4, which is 3 pi over 4. The tan is pi plus pi over 4, which is 5 pi over 4. And lastly, the cos, which we'll sneak in down here, is 2 pi subtract pi over 4, which is 7 pi over 4. Okay, so my 4 answers there are x is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. That's me found x. No more working to do. That's me done. Okay, so that's how you deal with a squared. Now that's all the different types of method 1. Okay, now there's lots of different tricks wrapped up in that. Radians, using the cast diagram, making sure you've got all the solutions at the end. But the main thing I want you to take from that is that if you have one trig term, you're putting everything to the other side. Okay, now what I've got for you now is I've got you, what's that, that's 12 different examples. Starts off kind of relatively straightforward, right up to the end where you've got this absolute beauty at the end. Okay, but either way, if you want to try and pause it, just run through it, and that'll do. Okay, 18 minutes already, jings, crivens. Okay, let's go on. Okay, so method 2. Right, method 2 is when we have more than one. Okay, we've got sine 2x and minus 6 sine x. Okay, so we've got a sine 2x, but we also have sine x. This is where the problem lies. Okay, this is where we have to go right the way back to the start, to this one here. Right, this is where I'm going to use this double angle. In fact, let's bring that in. Where am I there? Method 2, example 1. Let's have a wee paste that in. Let's move that over to the top here. Okay, so it's 5 sine 2x minus 6 sine x is an issue. We've got 2 different sine things. We've got the sine 2x and we've got the sine x. So what we need to do here, all the time it's pretty similar. The actual solving's not too tricky, but you need to get rid of that sine 2x, and we're going to do that from over here. So we know that sine 2x is equal to 2 sine x cos x. So when you sub that in, the 5's still going to be there, but now this is 2 sine x cos x. And we're still taking away 6 sine x, and that's equal to 0. Now, that 5 times 2 sine x, that's easy enough to deal with. That'll be 10 sine x cos x minus 6 sine x equals 0. And when these examples, you're always going to sub in, and then you're always going to factorise. Okay, so between the 10 and the 6, you've got a factor of 2. got a sine x in both. So 2 sine x is going to come out the front. Left in is 5 cos x minus 3, and that's equal to 0. Now, just like we did in that 5 with quadratics, we've got two factors. They're multiplying to get 0. So you've got two options for your solutions. You're going to have 2 sine x equals 0, or you're going to have 5 cos x minus 3 is equal to 0. Okay, and then you need to solve both strands. Now, 2 sine x equaling 0 really means sine x equals 0. And for anything at your extremities, at 0, at 1, at minus 1, you need to use your graph. So think about your sine graph. I'll just draw it beautifully neat at the bottom there. It equals 0 at the start, in the middle, at the end. So my solutions for that one there is x equals, I'm in degrees, yes I am, 0, 180 degrees, and 360 degrees. Okay, so that's your three solutions from that strand. This one here, dead easy. Cos x is equal to 3/5 when you rearrange it. Okay, so x is going to be the inverse cos of 3/5. Okay, so we're going to need our cast diagram again. Okay, we're talking positive cos, so there and there. The inverse cos of 3/5 incidentally is, give me a minute, I'll bang in my calculator. 53.1. Let's just call it 53 for ease. So my two quadrants, A is going to be 53.1 in that one, and in the fourth quadrant, C is going to be 360 subtract. Oh no, I've not called it 53.1, I've just called it 53. Apologies. So 360 subtract 53. I'm going to ignore the fact I just did that in my calculator. So there your solutions are going to be 53 and 307. So all 5 of them, that's your solutions to the question. Now you see what I mean? Actually the solving's dead easy. The first step is what the trick is in method 2. Okay, being able to sub in and then being able to factorise. Okay, example 2. Okay, we've got a cos 2x plus 5 equals 4 sine x. So we've got two different things. We've got a cos 2x and we've got a 4 sine x. Let's move that on again. Okay, there's our cheat sheet. Okay, we can use that. So cos 2x, we've got 3 options. Okay, 3 options for cos 2x. The trick here is 4 sine x. We've got another sine there, so we need to use one that's got a sine in it. So when we sub that in, it's going to be 1 minus 2 sine squared x plus 5 is equal to 4 sine x. Now, you always sub in, you always factorise. To factorise, we need to have everything equal to 0. Okay, now because that's a negative sine squared x, I'm going to take it to the other side so that my sine x squared, or my sine squared x will become positive. Okay, so if I take everything over the other side, I'm going to have nothing left there. 2 sine squared x is going to become positive when it moves over. I've still got a positive 4 sine x, and then the 1 add 5 would give me 6. So if I take that, that's going to be plus 6, and then when I take it to the other side, it's going to be minus 6. Okay, there's a common factor of 2 there, that's nice. I'm going to take out that common factor of 2, so it's going to be 0 is equal to sine squared x plus 2 sine x minus 3. And we need to factorise. Now factorising, well, factorising is easy for us now. The signs might make it a little bit more tricky. If you want, if you find it easier, go over to the right and just take out the signs and put in x's instead, and you'll find it. Oh, gee though, I can do that, no bother. So when you factorise it, it's going to be sine x plus 3 sine x minus 1. And then I've got 2 factors again. Now that one, sine x plus 3 equals 0. And that one gives me sine x minus 1 equals 0. So let's look at the blue strand. That means sine x equals negative 3. Okay. Now you type that on your calculator. If you've got a calculator, I'll tell you it's a math error, and we know why. Okay, thinking about our graph, the maximum of sin x can be is 1 and the lowest it can be is -1. So sin x will never be -3. That's impossible. So there's no solutions from that strand. This one, the red strand, nice and easy. Sin x equals 1. Now we know that sin x equals 1 only at that point. So x must be, what are we in, degrees, so 90 degrees. And that's your only solution. Okay, so two things, method 2, sub in one of your double angle formulas. So two things, method 2, double angle, another 2 involved there, and then factorise. Okay, last one we're going to look at, method 2, example 3. Okay, 3 cos 2x equals -1. I'm doing this in degrees. Why am I not put a radians one in here? Ah, well, you can do that anyway. So we've got two different things. We've got cos 2x and we've got a cos x. So this cos 2x, we need to get rid of that. So we've got three options. We're talking about a cos x there as well as a cos 2x. So I need to use that middle one. Okay, so it's going to be 3 multiplied by 2 cos squared x minus 1. All in brackets. It's really important that all gets multiplied by 3 plus cos x. And let's just take that -1 over to the other side because I'm not going to have to do that anyway, so it's +1 equals 0. Multiply out those brackets, that's going to be 6 cos squared x minus 3 plus cos x plus 1 is equal to 0. Which, let's tidy that up again, is 6 cos squared x plus cos x minus 2 is equal to 0. A little bit scarier because you've got the 6 at the front, but no match for us. So we need to factorise that again. If you feel like you want to make it look a little bit easier, swap out the cos's for x's and then factorise. So I'm going to have one in red. So we're going to have 2 brackets equal to 0. Let's see if I can figure this out in nil whack. I'm going to cheat, I'm going to pause. It took me no time at all. That, look at there it is there, just like magic. Okay, so you've got 2 strands. 3 cos x plus 2 must equal 0. Or, coming from the green, 2 cos x minus 1 equals 0. Okay, so red strand gives us cos x equals -2/3, and the green one gives us cos x equals 1/2. Okay, I'm in degrees, am I? Yep. Okay, so for there, x is equal to inverse cos of -2/3, which we know we need to go to our cast diagram. Okay, I'm working in cos negative, so I'm in these two. Inverse cos of 2/3 is 48. So my two solutions for that one, in the sine quadrant, it's 180 minus 48, which is equal to 132 degrees, and in the tan quadrant is 180 plus 48, so 228 degrees. Okay, so my solutions from here are x equals 132 degrees and 228 degrees. Okay, now for the green one, cos inverse of 1/2. Again, I'm going to have to do my cast diagram. Okay, I'm talking about a positive cos, so I'm in the first two. Inverse cos of 1/2. What's going on here? Inverse cos of 1/2 we know is 60 degrees. And then for the all, it's just going to be 60 then. And for the cos, it's 360 minus 60, which is 300. Which means for the green one, x is equal to 60 degrees and 300. So there's my solutions. Okay, right. Now, I apologise for the length of this. I just wanted to make sure I walked you through the whole thing. Obviously, you can pause and change and go back and do whatever you like.